Welcome to the review session of Bhopal Search Career Point. This is a video for the student of class 12 in the name of practice series for AHSC annual higher secondary examination as per the modified question pattern in the chapter chemical kinetics. Let us compare the patterns of examination for the practice series. Here full mark is 20, time duration is 45 minutes. Now, what type of time distribution will be there? एटी कि प्रकार समय विभाजन रहिबो क्वेश्चन पेपर रीडिंग एंड अंडरस्टैंडिंग 5 मिनिट्स क्वेश्चन पेपर पढ़िया पाई एवं क्वेश्चन पेपर को बुझिया पाई 5 मिनिट समय आमे देई परिबा एवं ग्रुप ए रे थिबा 5टी एमसीक्यू क्वेश्चन को गोटी को 1.5 मिनिट करी 7.5 मिनिट भितर आमको ग्रुप ए रो आंसर को कवर करिया को पड़िबो ग्रुप बी रे आमको 2टी प्रश्न उत्तर करिया पड़िबो प्रत्येक प्रश्न को 2 मार्क करी एवं 4 मिनिट करी 8 मिनिट भीतर आमको कवर करिया को पड़िबो ग्रुप सी रे 2टी 3 मार्किया प्रश्न उत्तर देवा पड़िबो प्रत्येक प्रश्न को 6 मिनिट करी आमको 12 मिनिट भीतर तार उत्तर लिखिया को पड़िबो ग्रुप डी रे आमको गोटिए दीर्घतम उत्तरमूलक प्रश्न रो उत्तर लिखिया को पड़िबो जहाँ को आमको 12.5 मिनिट भीतर लिखिया को पड़िबो यदि एही बळी भीतर आमे समय विभाजन को रखिबो आमको परीक्षा रे समय अभाव घटिबो नाही एबे नजर पकेबा आमे तार डिफरेंट फॉर्म ऑफ क्वेश्चन ऊपर वेलकम टू ऑल ऑफ यू टू द ग्रुप ए व्हिच all the questions are compulsory covering the multiple choice questions only each questions require not more than 1.5 minutes to write the answer thus एही ग्रुप रे हमको 5टी एमसीक्यू पई टोटल टाइम एलोटेड रहिबो मैक्सिममली 7.5 मिनिट Let us compare the first question. What is the unit of rate constant of first order reaction? आमे first order reaction रो unit टी कौन हबो देखिबा ऑप्शन ए मोल लीटर इनवर्स सेकंड इनवर्स ऑप्शन बी मोल इनवर्स लीटर सेकंड इनवर्स ऑप्शन सी सेकंड इनवर्स ऑप्शन डी मोल -2 लीटर स्क्वायर सेकंड इनवर्स students try to give the correct answer I mean rate constant of different order of nth order of reaction रो unit पाई आमे जनरली मन रखिताऊ मोल पर लीटर टू द पावर 1 minus n second inverse for zero order reaction n is equal to 0 so 1 minus n that is 1 minus 0 that is equal to 1 so for zero order reaction the unit is mole per liter per second but for first order reaction n is equal to 1 so mole liter inverse to the power 1 minus n 1 minus 1 is 0 so the unit is second inverse so इठारे प्रश्न मुताबक ऑप्शन सी रे सेकंड इनवर्स इज द करेक्ट आंसर किंतु जदि प्रश्नटी फर्स्ट ऑर्डर न दे सेकंड ऑर्डर देई थांता ताले सेकंड ऑर्डर देइतले तार उत्तर कोन रही थांता ना n is equal to 2 नबाको पड़ी थांता 1 minus 2 that is minus 1 मोल -1 लीटर सेकंड इनवर्स जदि सेकंड ऑर्डर रिएक्शन देई थांता ताले ऑप्शन बी आंसर हेई थांता यदि थर्ड ऑर्डर रिएक्शन देई थांता ऑप्शन डी आंसर हेई थांता एवं जीरो ऑर्डर रिएक्शन देइतिले ऑप्शन ए आंसर हेई थांता briefly we have to remember that is the unit of rate constant of nth order reaction is mole per liter to the power 1 minus n second inverse. Now, let us compare the second question of this group. The overall order of reaction which is rate expression rate is equal to k into a to the power half and b to the power 3 by 2 each. Option A 0 1, option B 2, option C 3, option D 4. The students try to give the correct answer. जो रेट एक्सप्रेशन रेट टी के इंटू ए टू दी पावर 1 by 2 एंड बी कनसंट्रेशन बी टू दी पावर 3 by 2 होइतिबो तालो ओवरऑल ऑर्डर केते हेबो ना इट द सम ऑफ द एक्सपोनेंट व्हिच रेज टू दी पावर दैट इज ए रो पावर केते अछि ना हाफ बी रो पावर अछि 3 by 2 देयर सम हाफ प्लस 3 by 2 is equal to 4 by 2 that is equal to 2 so option B is the correct answer Now, let us come for the next question. That is question number 3. The energy purchased by the activated complex is option A, activation energy, option B, free energy, option C, threshold energy, option D, kinetic energy. Students, try to give the correct answer. The energy purchased by the activated complex is nothing but the threshold energy. That is option C is the correct answer. But what is activation energy? Now the excess amount of energy which must be supplied to the reactant molecule to form the activated complex to attain threshold energy. ଆମେ ତାକୁ ହିଁ କହିବା activation energy. Activation energy is always less than the threshold energy. Now, let us come to the next question. That is question number 4. The half-life period of first order reaction is 6.93 seconds. Its rate constant is option A 100 second inverse, option B 10 second inverse, option C 1 second inverse, option D 0.1 second inverse. Students try to give the correct answer. The half-life period of first order reaction is 6.93 seconds. So rate constant is equal to 0.693 by 6.93, that is equal to 1 by 10, that is equal to 0.1 second inverse. That is option D is the correct answer. Now let us come for the next question. That is the last question of this group. What will be the amount of iodine 128 which TF is equal to 25 minutes left after 50 minutes if it follows first order kinetics? ଯଦି ଫାର୍ଷ୍ଟ ଅର୍ଡର କାଇନେଟିକ୍ସ ଫଲୋ କରୁଥିବ ଆଉ TF is equal to 25 minutes ହେଇଥିବ, ତେବେ କେତେ ଆମାଉଣ୍ଟ ଅଫ୍ ଆୟୋଡିନ୍ 128 ରହିବ ଆଫ୍ଟର 50 minutes? ଅପସନ୍ ଏ 1/2, ଅପସନ୍ ବି 1/3, ଅପସନ୍ ସି 1/4, ଅପସନ୍ ଡି 1/8. 25 minutes ଯଦି ତାର ହାଫ୍ ଲାଇଫ୍ ପିରିୟଡ଼ ହୁଏ ତାହେଲେ 50 minutes means 2 TF. So the remaining amount will be 1/4 of the original amount. So option C is the correct answer. That is 1/4 amount of I-128 will left after 50 minutes. Now let us come to the next group. That is, let us go to the group B. 2 questions is to be answered out of 4. Each question requires not more than 4 minutes to write the answer. एभଳି ଏଠି 2ଟି ପ୍ରଶ୍ନ ପାଇଁ ଆମକୁ 4 ମାର୍କ ରହିବ ଆଉ ପ୍ରତ୍ୟେକ ପ୍ରଶ୍ନକୁ 4 ମିନିଟ୍ କରି ଆମକୁ 8 ମିନିଟ୍ ଭିତରେ ଏହି ଗ୍ରୁପ୍ ବିର ଉତ୍ତରଟିକୁ ଲେଖିବାକୁ ପଡ଼ିବ। ଏବେ ନଜର ପକାଇବା ଆମେ ପ୍ରଥମ ପ୍ରଶ୍ନ ଉପରେ। describe the with a suitable example describe the fractional order of reaction. What do we mean by fractional order of reaction? The reaction whose rate depends upon the fractional number of molar concentration of the reactants is called fractional order reaction. Now let us compare example. The decomposition of acetaldehyde to give methane and carbon monoxide. Here the rate equation is rate is equal to CH3CHO whole to the power 3/2. That is order of reaction is equal to 1 plus 1/2, that is 3/2. So it is a fractional order reaction. Again, the formation of HBr from H2 and Br2 is also a fractional order reaction, where the order of reaction is also 3/2. Now derive the Arrhenius equation. Arrhenius equation, the quantitative relationship between the rate constant and temperature is proposed by Arrhenius in the form of equation is called Arrhenius equation. The relationship is as follows: K is equal to A into e to the power minus E by RT. What is K? K is the rate constant, A is the frequency vector, A is the activation energy, R is the gas constant, and T is the absolute temperature in Kelvin. Now, by taking logarithm, here the exponential factor e to the power minus E by RT represent the fraction of molecules undergoing effective collisions. Taking the logarithm of equation 1, we get ln k is equal to ln A minus EA by RT, as ln E is equal to 1. By converting to natural logarithm, we will get 2.303 log k is equal to 2.303 log A minus EA by RT, implies 2 log k is equal to log A minus EA by 2.303 RT. Let us come for the next question. The apply period of a first order reaction is 30 minutes. How much time is required for 75 completion of the reaction? गोटे फास्ट अर्डर रिएक्शन दि जाइए तार अप्लाई पीरियड हूँ 30 मिनिट 75% कंप्लीशन होगापाई केती समय लगे द अप्लाई पीरियड ऑफ फर्स्ट ऑर्डर रिएक्शन इज 30 मिनिट्स मीन्स टी हाफ इज इक्वल टू 30 मिनिट्स फॉर 75 कंप्लीशन इफ A0 is equal to 100 then A is equal to 25 कारण 75 ऑलरेडी कंप्लीटेड हो जाइथिबो नाउ A by A0 is equal to 25 by 100 that is equal to 1 by 4 that is equal to 1 by 2 to the power n. Thus आम हाफ टू the power n फॉर्मूला को नहीं गलु here n is equal to 2 so t is equal to 2 t half implies t is equal to 2 into t half that is 2 into 30 minutes that is equal to 60 minutes. Thus 60 minutes is required for 75 completion of the reaction. Let us come for the next question. What is activation energy? How does it influences the rate of the reaction? I mean activation energy कहले कौन बुझिबा? The excess amount of energy which must be supplied to the reactant molecules to undergo chemical reactions and to form product molecules is called activation energy, EA. How does it influences the rate of reaction? Mathematically, the difference between the threshold energy ETH and the energy of the reactant ER is called activation energy. We can write down mathematically EA is equal to ETH minus ER. How does it affect the rate of reaction? Larger the activation energy, slower will be the rate of reaction, and lesser the activation energy, faster will be the rate of reaction. Now, welcome to all of you to the group C of the modified question pattern. Here 2 questions is to be answered out of 4 according to the practice series. Each question requires not more than 6 minutes to write the answer. प्रति क्वेश्चन को 3 मार्क करी आमको यही ग्रुप रे 6 मार्क उत्तर लिखा पड़ो आ प्रत्येक क्वेश्चन को 6 मिनिट करी आमको ग्रुप सी उत्तर 12 मिनिट भितर लिखा पड़ो. Let us come to the first question of this group. Briefly describe the collision theory. How does activation energy calculated by using it? Let us consider a general reaction A plus B gives us C plus D. Now, the reactants have the average energy ER and the products have the average energy EP. Whenever A and B collide with each other, the energy of the reactants gradually increases till it reaches the top of the energy barrier to form the activated complex. The reaction cannot occur until the reactant molecules A collide with reactant molecule B. When they collide with each other, the energy increases until reach the top of the energy barrier and form the activated complex. The energy required to form the activated complex is called activation energy. The energy of the activated complex is called threshold energy. So the difference between the threshold energy ETH and the energy of the reactants that is ER is called the activation energy. Mathematically we can say EA is equal to ETH minus ER. For example, consider the reaction between H2 and I2 to form HI. H2 and I2 collide with each other to form the activated complex where the breaking of bond between H and I and A takes place simultaneously with the making of new bonds H and I. Thus, finally, 2 HI molecules are formed. Let us come to the second question of this group. Define apply period. Establish the relation between T half and rate constant K of the first order reaction. आम देखिए प्रथम अप्लाई पीरियड डेफिनेशन कौन इट इज द टाइम इट इज डिफाइंड एज द टाइम taken to reduce the initial concentration of the reactants to half of its initial value. It is denoted by the symbol T half. If the initial concentration of A0 when T is equal to 0, then T is equal to T half, A must be equal to A0 by 2. Putting these values in the rate equation, we will get K1 is equal to 2.303 by T half log A0 by A0 by 2. That is T half is equal to 2.303 into log 2 by K1. That is 2.303 into log 2 value of 0.3010 by K1 implies T half is equal to 0.693 by K1. This is the relationship between half-life period and the rate constant of first order reaction. Distinguish between molecularity and order of reaction. What do you mean by molecularity of a reaction? The number of reacting species which collide simultaneously to bring about the chemical reaction is called molecularity of a reaction. What do you mean by order of reaction? The sum of the powers of the molar concentration of reactants in the rate equation is called the order of the reaction. Second point देखिए, what is molecularity of the reaction is always a whole number and never be zero or a fraction. But the order of reaction may be a whole number, zero or a fraction. The molecularity pertains to the single step or the slowest step of the complex reaction. But the order of reaction pertains to the reaction as a whole. Now let us come for the next point, that is the molecularity can be obtained from the valence chemical equation, but the order of reaction cannot be obtained from a valence chemical equation. It can be obtained from experiment. Molecularity refers to the mechanism through which the reaction proceeds, but the order of reaction does not refer to the mechanism through which the reaction proceeds. What are the different factors affecting the rate of a chemical reaction? आमे different factors कथा discussion करिबा. The rate of chemical reaction is affected by several factors, including concentration of the reactants. Increasing the concentration of the reactants increases the number of particles that collide, which increases the rate of reaction. Temperature. Increasing the temperature of the system increases the energy of the system, which increases the frequency of collisions between the particles and increases the rate of reaction. Third factor को देखिए, presence of catalyst. A catalyst increases the rate of the reaction by lowering the activation energy. Catalysts work by increasing the frequency of collisions between the reactants and increases the rate of reaction. Other factors that affect the rate of a chemical reaction include the pressure of the reacting gases and the surface area of the solid reactants. If the surface area increases, then the rate of reaction also increases. Welcome to all of you to the group D of the modified question pattern. Here, as per the practice series, one question is to be answered out of two. Each question requires not more than 12.5 minutes to write the answer. एटी 5 मार्क उत्तर पाई आमे मैक्सिममली 12.5 मिनिट समय दे परिबा. प्रथम क्वेश्चन पर नजर पकेबा. There are the equations for the rate constant of zero order reaction. Explain how does its half-life period depend upon the initial concentration. Now, derivation of the rate constant of zero order reaction. Let us consider a reaction A gives us products. Let A0 be the constant of the reactants at time T0, T is equal to 0, and A be the constant of the reactants at time T, and K0 be the rate constant. According to law of mass action, rate is equal to K0 into concentration by A to the power 0, that is equal to K0. According to rate law, rate is equal to minus dA by dt. From equation 1 and 2, we can write minus dA by dt is equal to K0, implies minus dA is equal to K0 dt. Integrating both sides of equation 3, we get minus A is equal to K0t plus C, where C is the integration constant. When T is equal to 0, then A is equal to A0. Putting the this value in equation 4, we get C is equal to minus A0. Now by putting the value of C in equation 4, we get that is minus A is equal to K0T minus A0, implies K0T is equal to A0 minus A, implies K0 is equal to A0 minus A by T. This is the equation for rate constant of zero order reaction. Now, half-life period of zero order reaction. It is defined as the time taken to reduce the initial concentration of the reactants to half of its initial value. It is denoted by the symbol T half. If the initial concentration is A0, then T is equal to, when T is equal to 0, then at T is equal to T half, A is equal to A0 by 2. Putting these values in the equation, rate equation, we get K0 is equal to A0 minus A0 by 2 by T half, that is equal to A0 by 2 T half, implies T half is equal to A0 by 2 I sub K0. Thus the half-life period for zero order reaction is directly proportional to the initial concentration of the reactants. Let us come for the second question of this group. Derive the equation for the rate constant of first order reaction and solve a problem. A first order reaction takes 69.3 minutes for 50% completion. How much time will be needed for 80% completion? प्रथम आम डेरिवेशन करवा रेट constant for first order reaction. Let us consider a reaction A gives C product. Let A0 be the concentration of reactants at time T is equal to 0. A be the concentration of the reactants at time T, and K1 be the concentration rate constant of the reaction. Now, according to law of mass action, rate is equal to K1 into concentration by A to the power 1. That is, rate is equal to K1A. And according to rate equation, rate is equal to minus dA by dt. From equation 1 and 2, we get rate minus dA by dt is equal to K1A. Rearranging this, we will get minus dA by A is equal to K1 dt. Integrating both sides of this equation 3, we get integration of minus dA by A is equal to K1 integration of dt, implies minus ln A is equal to K1 Tc, where C is the integration constant. When T is equal to 0, then concentration of A is equal to A0. Putting these values in equation 4, we get C is equal to minus ln A0. By putting the value of C in equation 4, we get minus ln A is equal to K1T minus ln A0. Implies K1T is equal to ln A0 minus ln A, that is equal to ln A0 by A, implies K1 is equal to 1 by T ln A0 by A. Taking the natural logarithm, we can write K1 is equal to 2.303 by T log A0 by A. This is the equation for rate constant for first order reaction. Now let us come for solving the problem. We know that T half is equal to 0.693 by K1, implies K1 is equal to 0.693 by T half. At T half हमको 69.3 दिया है, so K1 is calculated to be 0.01 minute inverse. Again, T is equal to 2.303 by K1 into log N0 by N. Now, putting the values, the 2.303 by K1 is equal to 0.01 log 100 by 20, because 80% completion is माने N0 यदि 100 हुए N टा 20 होगा. So this will be equal to 2.303 by 0.01 into log 5. Now 2.303 by 0.01 is equal to 230.3 into log 5 को हमें log 10 minus log 2 कर देलो. Then the value is calculated to be 160.97 minutes. Thus, the time required for 80% completion of the reaction is approximately 160.97 minutes. Thanks for watching Bhopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.